So before we move on our discussion to organic reactions, I believe that it is a good idea to first stop here and talk about intermolecular, or what we refer to as intermolecular, as well as what we refer to as interatomic forces, right? So sometimes you find that when people refer to interatomic forces, they also might say it is intramolecular forces. Intramolecular forces. So interatomic as well as intramolecular forces refer to one of the same thing, right? Intermolecular means between molecules, and an interatomic simply refers between atoms within one molecule. So there are two, like I mentioned, there are two types of forces that we're gonna talk about. Now let us try to differentiate between the two. I'm gonna try to move this a little bit and see if I'll succeed. Yeah. So let us try to differentiate between the two. So consider that we had two methyl thing is there, not methyl, two methane, two methane molecules, right? With another methane. So it's one carbon and four hydrogen. It's CH4. It's methane. So we can have forces between molecule 1 and molecule 2 of methane, right? And also, however, we can also have a force here between the atoms. Let me just do this. Between the atoms of a particular methane, right? We can have a force between what is this atom? Carbon as well as hydrogen, because one of them is slightly positive and the other one is slightly negative. So this force that we find here between specific molecules, we call that intermolecular. So it's between molecules. It's called an intermolecular force, or we're gonna abbreviate it and say IMF, right? And then this force here between atoms of the same molecule, we can refer to that as intramolecular forces. Intramolecular, I hope you can still see, or interatomic forces. It means the same thing. So interatomic, between atoms, right? So be able to know that those two distinctions. And then having said that, we can continue and say we have three types of intermolecular forces, and those intermolecular forces sometimes are called, so IMF, oh my goodness, IMF, intermolecular forces. This is what we primarily going to be focusing on. Sometimes they are called van der Waals forces, if I'm not mistaken. Yeah, van der Waals forces, right? And there are three types that we're going to concentrate on. The first one is hydrogen bonding. Hydrogen bonding, which is the strongest of intermolecular forces, or the strongest van der Waals forces. Hydrogen bonding. The second one is think about it, dipole forces. It's the second strongest of those intermolecular forces, dipole forces. And the third one, the last one that you're gonna talk about, is what we call induced dipole forces, right? And sometimes these induced dipole forces are referred to as London forces. So those are the three types of intermolecular forces that we're going to talk about: hydrogen bonding, dipole forces, as well as induced dipole forces, or what is normally referred to as London forces. Right, so now let us talk about each of them separately. So let us first start with the weakest type of intermolecular forces, which are induced dipole forces, or what some people refer to as London forces, right? Like we've already mentioned. And these forces actually occur between non-polar molecules. So what happens is that what we refer to as non-polar molecules, because we've already spoken a lot about organic molecules, we are simply referring to alkanes, alkenes, as well as alkynes. So those are your non-polar molecules. And we've already taken an example. You can take an example between two methane molecules as earlier. So those types of forces that will occur between this two methane, it can be ethane or whatever. We will call them induced dipole forces. And this they occur because between nonpolar molecules, because these nonpolar molecules are gonna form what we call a temporary a temporary dipole, or what we refer to as an induced dipole. So these non-polar molecules form what we call it is a temporary dipole or an induced dipole. And then these dipoles will be attracted to each other. So for example, this one might be slightly negative, and then this one will be slightly positive, and maybe this one might be slightly negative, I'm lying, slightly positive, and then this one will be slightly negative. So it will form a sort of a temporary dipole, and then these two dipoles will then be attracted. The negative will be attracted to the positive, and this positive to this negative. So then we'll have those London forces between the two, right? Like I mentioned, examples of nonpolar molecules can include all your alkanes, alkenes, as well as your alkynes. So the second type of force, of intermolecular force, that we can talk about are what is referred to as dipole forces. Let me write that quickly. It's dipole forces. So these forces are stronger than induced dipole forces, but are weaker than hydrogen bonding. So one thing to know. And these forces occur between polar molecules. Polar molecules, and then they'll then have, so remember, if you have a thingy, a dipole, that's when we have maybe one atom being slightly positive, and the other atom, if they are joined, let's say C to oxygen, and the other one being slightly negative, and then they form a sort of a dipole, right? So that's what is referred to. So we have those polar molecules, and then something that I wanted to say. So what is it? So polar molecules can include all your aldehydes. So try to remember what aldehydes look like: ketones, esters, as well as haloalkanes. So for example, we may have an aldehyde like this one here, ethanol, right? And there's going to be a hydrogen, and then this part will be slightly positive, while this part is slightly negative. And then we may have another aldehyde. Let's say we have the same ethanol on the other side. This one will be slightly positive, and this one will be slightly negative. And then these two, the slightly positive part of the carbon of this atom, of this molecule, will be attracted to the slightly negative oxygen of this atom, and then we have those dipole forces. So because they attract each other, and they are stronger than induced dipole forces. So remember, even with the same thing with haloalkanes, let's take this one, we have chlorine there, and then we can take another, this is H here. This part will be slightly positive, and then this part will be slightly negative. This is in reference to their electronegativity, slightly negative. And then here, slightly positive, slightly negative, right? And then this slightly negative part will be attracted to this slightly positive part of the other molecule, and the same thing here, and then you form those dipole forces, right? I hope that is making sense, right? Cool. The last one that you're gonna talk about, which are our strongest intermolecular forces, are what we actually refer to as hydrogen bonding. So let me write down hydrogen bonding, right? And what is unique about these types of molecular forces? They are actually forces between molecules in which hydrogen, and I want you to keep attention, hydrogen is covalently bonded to either nitrogen, oxygen, or fluorine. It's a sort of a special type of dipole if you think about it. So an example may be alcohols. So we may have an alcohol molecule, ethanol, OH there, and then we may have as well. So here you notice that this one will be slightly negative and this one will be slightly positive. So these two are forming a sort of a dipole, right? I'm actually lying. I'm actually really, really lying. So the third type of intermolecular forces that we can refer to are what is referred to as hydrogen bonding, right? So in terms of hydrogen bonding, these ones are the strongest intermolecular forces, and these forces actually occur. So they occur between molecules in which hydrogen is covalently bonded to nitrogen, oxygen, or fluorine. If you think about it, and you'll see why, it's almost like the special type of dipole forces. And like we've mentioned, they are the strongest intermolecular forces, and they occur between molecules that are strongly polar, that contain hydrogen. So a certain hydrogen may be bonded to perhaps nitrogen, or oxygen, or fluorine. So this hydrogen may be bonded to oxygen, right? And then you'd find that this part is slightly negative because oxygen is more electronegative and this one is more electropositive, right? And then this one will be slightly positive. So examples of molecules that exhibit hydrogen bonding, we can have alcohols because of that OH, remember? Or what is it? Carboxylic acid. So remember, so here, because of this OH, then we will have a sort of a slightly negative, slightly negative, and then this one will be slightly positive. It just looks messy now. And then we have maybe let's see, carboxylic acids as well. They also have hydrogen bonding because we have an hydrogen that is bonded covalently to an oxygen, right? And then we have H, right? Cool. This one will be slightly negative, slightly positive, right? And they form a sort of a dipole. So that is just something important to know. Then if we were to draw another alcohol here, and then do this, I'm just explaining this in the simplest way I know how. So this part might be this slightly negative part of this molecule might be attracted to this slightly positive part of this um of this molecule, right? So they are quite strong. And the same thing here, this slightly positive hydrogen will be attracted to this highly electronegative oxygen there. So we've now spoken about these three types of intermolecular forces. So now we can try to move our discussion to how do these intermolecular forces relate to what is it relate to boiling point, melting point, as well as all of this you need to know. Boiling point, the definition of these things you need to know: boiling point, melting point, and vapor pressure. So you need to know all of these definitions. You need to describe what are intermolecular forces, what are intramolecular forces, what are hydrogen bonding, what else, dipole forces, as well as induced dipole forces. You need to be able to define those, in order to prepare for your paper too, right? So this is something interesting. I'm gonna just be very brief about it. Let's refer to boiling point. And the boiling point is actually referred to, the standard definition is that it is the temperature at which the vapor pressure of a substance equals the atmospheric pressure. So at that point, your liquid or whatever it is, it will start to boil. And then the relationship between boiling point and intermolecular forces is that the stronger the intermolecular forces, so stronger IMF, it means the boiling point is higher. And I'm going to write boiling point as BP. So BP is going to be higher. Secondly, let us define melting point. Melting point, the standard definition is that it is the temperature at which the solid and the liquid phases of a substance are at equilibrium. So be able to know that definition. And we know that the stronger the IMF, the intermolecular force between the two molecules, it will be the stronger, the stronger the intermolecular forces, the higher the melting point. So I'm gonna write melting point as MP. And then just look here, the last thing we have is vapor pressure. And vapor pressure is defined as the pressure exerted by a vapor at equilibrium with its liquid in a closed system. No, that is a lot of English. Just know those definitions. You can try to memorize them. The important thing is that to know their effects on intermolecular forces. And now we're saying the stronger the intermolecular forces between your molecules, the weaker or the lower the vapor pressure. So be able to know this relationship. Stronger the intermolecular forces, the higher the boiling point. The stronger the intermolecular force, the higher the melting point. Because now more energy, if the intermolecular force is stronger, you will need more energy to kind of break those two molecules apart. If you think about it logically. And then the stronger the intermolecular forces, the lower the vapor pressure, right? And now I want you to now think. Let us try to do an activity where we try to organize intermolecular forces in terms of increasing strength. So I've already mentioned this. So the strongest, if you maybe from here, your intermolecular forces are increasing. So IMF increasing in this direction, meaning here we'll find hydrogen bonding, which is our strongest intermolecular force. And then perhaps there, the middle, we will find dipole forces, right? And then there at the other end, the weakest of ours are London forces or induced dipole forces. And then so molecules that exhibit hydrogen bonding can be your carboxylic acids, right? As well as your alcohols. Molecules that that exhibit dipole forces can be your aldehydes, your ketones, your esters, as well as lastly your haloalkanes. And then here, induced dipole forces are alkanes, if we've mentioned alkanes, alkenes, as well as, what's the other one? Alkynes, so all the hydrocarbons. So what is this saying to me? This is saying to me that carboxylic acids have a stronger hydrogen bonding in comparison to alkanes, perhaps. but we're still gonna continue a little bit about this. So for example, let's say they gave you a carboxylic acid, and this is it, and they also gave you an alcohol, right? No, let me not say they didn't give you an alcohol. Maybe they gave you an alkane, and they said, the question said to you, which one has the highest what do you call, which one has the was which one will between the two will have the highest boiling point? We know already that the stronger the IMF, the higher the boiling point. And between carboxylic acid and alkanes, uh, molecules that have the highest uh, intermolecular forces are carboxylic acids, meaning this will have the highest boiling point in comparison to this alkane. It will also have the highest melting point, but then it will have the lowest vapor pressure, right? So be able to kind of explain those things when you are asked maybe a question like that in your exam. And another consideration we can make is that, okay, let us do this. So this is in terms of increasing IMF again. So your intermolecular forces are increasing in this direction. Let me write it: increasing IMF, because more energy will be required to kind of break to those two molecules, whatever, right? And then here, let's say we have hydrocarbons. And I know this is a repetition, but I want you to kind of understand it. And here maybe we might have haloalkanes, and then esters, and then we'll have alcohols, and finally we'll have carboxylic acid. So what is this telling me? Carboxylic acids have a stronger intermolecular forces than alcohols. Alcohols have stronger intermolecular forces than esters, and esters have stronger intermolecular forces than haloalkanes, and haloalkanes have stronger intermolecular forces than what you call hydrocarbons. So remember, hydrocarbons are your alkenes, alkanes, as well as alkynes, right? And then also another consideration we can make is if we say this is in terms of increasing IMF, but now instead of considering the functional group, we talk about the chain length. So let us compare these two. So let's say you had methane, ethane. So the number of carbon atoms are increasing, as you can see. And then you have propane, and it can continue up until right. So you notice that what is this, propane will have a higher intermolecular force than ethane, and then ethane will have a higher intermolecular, stronger, I don't want to say higher, stronger intermolecular forces than your methane. So this means as the number of carbon atoms increase in your chain, the intermolecular force will increase. So meaning if you're asking a question which between these two will have the highest boiling point, this will have the highest boiling point because the intermolecular force in propane are stronger than in ethane, as well as stronger than in methane, right? And then the last thing that we can talk about that is quite interesting. So now let us consider a situation such as this one. So where we have branching. So here we have a linear molecule. There's no branching right there. 1, 2, 3, 4, 5. So it's, what is it? It's pentane. And then here you see that it's still 5 carbon atoms, but now we have this methyl group on the side, and here we have a number of methyl groups on the side. So what happens is that as more branching results in what we say it's a smaller surface area, and then the strength of the intermolecular force will actually decrease. So this is organized in terms of decreasing IMF. This means that this compound here at the end has the weakest intermolecular force if we compare it to this atom on this other side. So those are some of the things that you have to know. You have to be able to answer questions about them. I know this lesson was a bit theoretical, it was way too many words, but then yeah, take time and think about it and try to absorb everything that we've just spoken about. And then in the next few lessons, we're going to talk about what is it, organic reactions.